Okay, welcome to experiment number 3 of EE310. This is the circuit on the experiment on wave shaping diode circuits, and we're going to be doing in 3 parts. We're going to do the clamper circuit first, and then part 2 we'll do the clipper circuit. Part 3 we're going to do a voltage regulator line and load test. So the clamper circuit, you remember this circuit from lecture. This is a circuit that takes an AC waveform and clamps its top or bottom edge to a very specific DC level. And in this case, we're asked to do a 1 kilohertz waveform and design a circuit that clamps its top to 5 volts. So regardless of its frequency, regardless of its wave shape, regardless of its amplitude, the top of the wave is always going to come out stuck at 5 volts. So let's say we're doing a triangle wave. Regardless of how big the wave is, the top is going to be at 5. So to do the design, there are just very few things to take into consideration. One, though, is that you'd like to have your RC time constant be much, much slower than the frequency of the wave. If you don't do that, what happens is your wave is going to start to decay between cycles. You're going to get like this, and you're not going to get the wave intact. You're going to have the capacitor charging and discharging between cycles, and we don't want to do that. So in mathematical terms, we'd like to have RC be much larger than 1 over our frequency, much larger than our period. So this is set up for a 1 kilohertz wave. That means we'd like to have R times C much greater than 1 millisecond. So let's go 100 to 1. 100 to 1 is a safe margin. So let's say RC is going to be equal to 100 milliseconds. And we can basically choose any values for that we like. So let's choose values that are conveniently available. I chose a 1 microfarad capacitor and a resistor of 100K, brown, black, yellow. So the power spec on these is minimal. These can be quarter-watt resistors. That's fine. The capacitor, 1 microfarad, lots of choices for that as well. One other thing is because this is centered at 0 volts and this is centered above, top at 5 volts, our capacitor is going to be charged plus to minus this way. The DC level on the capacitor here is generally going to be above the DC level there. So if it's a polarized capacitor, put the plus side on the right. So what we're going to do now is we're just going to build the circuit, make sure that it works. We're going to vary the wave shape. We're going to do sine, triangle, and square. We'll vary the amplitude, vary the frequency, and what we'll hopefully see is that the top of the wave will still be clamped to 5 volts. The only other thing left is a value for Vref. When this diode is on, it's going to have a plus to minus 0.7. So we have to set Vref is equal to 4.3 volts. So we'll set that with a DC meter, and then we'll be able to watch your circuit work. And then we'll also try varying this DC, and we'll see how the top level changes. So that's the procedure for part 1. So here we are. We're going to start with our clamper circuit. We have lined up our scope, our signal generator, and our DC reference supply, and we have set up our breadboard with the common ground, and then 2 voltages. We'll use 1 for AC, 1 for DC, and wire them onto the breadboard. So we're going to start by coming off our AC supply, which is this one here. We have 2 leads. We're going to plug the reference ground over here, and we're doing AC over there, okay? And let's make sure we turn the amplitude all the way down, and we got to do something to get these wires out of the way, so I'm just going to tuck them under other stuff. Okay. All right, so that's our AC source, and then okay, good, more wires, good. And then for, we're gonna come off of our AC source through our capacitor. So this is our 1 microfarad capacitor, and this one is not polarized, I believe.
No.
It's not polarized, that's good. So our AC source is going to come in to over here. We're going to go through our capacitor from there to maybe 3 holes over. And then we're going to have our diode pointing down. So this is our general purpose 1N4001 diode. And the stripe is here, we're going to have the stripe away from the capacitor. So we'll put that there. These diodes use a slightly thicker lead, so they can give you trouble plugging into the breadboards, but we'll make them go. Okay, so there's the diode coming down to there. And then from there, we have our DC voltage. So let's turn our voltage all the way down over here. And then we are going to use a red lead coming off of our output number 1, going to, oops, there. And then the ground is going to come from here. The negative is already strapped to ground on the signal generator, on the power supply, so we don't have to worry about connecting that. And we're going to ground the DC to the AC to the same source, like so. And then the voltage here is going to go to the bottom of the diode, right there. And then we're also going to put our resistor. We have our 100K resistor here. It's not on the diagram, but it goes across the diode. So we're going to put that across the diode, there and there. Okay. And then we can connect up our scope for our input and output. So this is all set. And we're going to use channel 1, the yellow probe, for the input. Okay, and the input is going to be on the AC input, which is going to be this lead here, where it comes into the capacitor. And then the channel 2 probe is going to be on the output, which is at the other side of the capacitor. So we're going to clip that onto there. And we do need to ground one of our scope probes. We don't have to ground both of them. Let's see if this will reach over to there. And if it doesn't, we will just go get another jumper. It looks like we're reaching. Okay, so the next thing we need to do is we can go ahead and dial up 1 kilohertz. Here, let's turn the voltage all the way down. Dial up 1 kilohertz over here. We're on the 1 kilohertz range. We're pretty close. And amplitude, and see if we can get that to show up on the scope. Horizontal. There we go. Right now we're set up for a triangle wave. Okay, but we can put this on a sine wave also. Okay, so it looks like we're set. We're at 1 kilohertz and we're at an amplitude of 2 volts per division. So that's around about 8 volts peak to peak. It's as good a place to start as any. And now that we know that's right, we can shrink that and move it to the top of the screen. And then we will recruit channel 2, which will show us what's going on the bottom of the screen. Okay, so, okay. And it looks like channel 2 they're both on 5 volts per division now. Okay, now let's see where we're clamping to. We have channel 2 on DC coupling. And actually, let's turn up the scale a little bit so we can get a closer view. And what we should be seeing with the voltage here, it's set to 0, is that the top of the wave is clamped to plus 0.7. Okay, and so as we turn this voltage up, we're going to be clamping to a higher and higher value. And we're changing the level that we're clamping to. So we can see the top of the level here. We're supposed to be clamping at 3 volts, so that's 1.5 divisions up. Right about there. So we'll see that the top of the wave is always clamped to this DC level here. And what we see is if you change the frequency of the wave, it stays right there. If you change the amplitude of the wave, the top stays right there. And even if you change the shape of the wave, if you switch to a triangle, you'll see that also the top of the wave stands right there. One other thing to notice is you get a little bit of a rounding here at the top of the triangle wave. That represents a very brief instant where the diode comes on and holds the wave to that level. And so you don't notice that on the bottom of the wave, but on the top of the wave, the diode is coming on and just clamping, giving a little blip of current right there, and that's costing us the very top of the wave. However, if we go to square wave, you won't even see that. Whoops, it doesn't like the square wave very well. Let's see if we can get that to show up a little better. But you can see even with the square wave, This little decay here represents the RC time constant of the 100K resistor and the 1 microfarad capacitor. But again, you can change the voltage level that you're clipping to. You can change the frequency of the wave. You can change the amplitude of the wave. How about if we change the offset of the wave? Let's introduce some offset. So you see channel 1 moving up and down. Channel 2 does not change its DC offset. It stays put where it is. So this hopefully demonstrates what the clamper does, and seems to work pretty well.